And this is my lab 5 for Physics 2211, the creative or make your own, and my choice was collision and conservation of momentum. The contents of this lab video will be lab introductions, 2 fundamental physics concepts, procedures that follow the lab, data analysis of after the lab, conclusions that will be drawn from the data analysis, as well as possible errors and questions at the end. Now, the main lab objective was to compare and see how momentum was conserved between 2 objects in a collision. And some basic lab information before we start is that the objects are 2 dynamic carts, one that will have initial velocity, while the other is remaining still. Tools that we will use are Tracker, Google Sheets, as well as GlowScript. Now, some fundamental physics concepts. First, is it Newton's first law, or an object will stay in motion or stay still unless an external force interferes. 2, Newton's second law, F is equal to ma, and momentum, and the principle, net force is equal to the change in momentum of a system divided by the time, as we can see below, where F net is equal to delta P over delta T. 3, formulas, the velocity update formula, position update formula, as well as the momentum equation, or momentum is equal to mass times velocity, will be needed for this lab. The procedure following this lab will be: Step 1, record a video of 2 carts of the same mass, one that is moving while the second is at rest. Step 2 is import the video into the tracker application and set up a frame by frame to see the observed positions of each graft. Use GlowScript to create a computational model of the cart's predicted motion using the initial velocity from the data from the tracker. Step 4 is to gather data from GlowScript with the predicted motion. And finally, compare both models in order to create a final model. As you can see here on a tracker application, there's observed position of initial position of cart 1, which starts at the left, will be r is equal to position of negative 0.0621455 as initial position, and initial velocity being v is equal to 0.0964 meters per second, while cart 2 will be at the initial position of 0 and initial velocity of 0. Now, as we can see here, our observed versus predicted graphs. On the left is cart 1, on the right is cart 2. Cart 1 starts with initial velocity going up, but then soon flattens out, showing that there's a decrease, or the momentum is being conserved and transferred over to cart 2, as you can see here, as it has the same velocity as from cart 1. Now, the computational model, GlowScript. This is the main code that I used, as well as the position update over here, as well as cart velocity update, as well as the P after and kinetic final and position or momentum final, momentum equations as kinetic equations. Observe, predict, graph again. Here's the actual model that we used for on GlowScript. Cart 1 has initial velocity. This is after the collision, where velocity 1 final will be equal to 0, or very small number, which is negligible, and V2, who will have the initial velocity of 0 turn the final velocity, as well as from the cart 1's initial velocity, showing a conservation of momentum. As you can see here, before collision, the P total is 0.04820, and after collision it is also 0.04820, and K total before is 0.00232, while after K total is 0.00221, very similar, almost negligible difference. And then the initial velocity of the cart 1 is 0.09640, final is 0.00241, which is also just 0. U2 is 0, the initial velocity of the second cart is 0. However, after, the final is 0.009399, which is very similar to the initial velocity of cart 1, showing the conservation of momentum, as also shown on the graph bottom here. Now, some possible errors are position tracking. While using the tracker application, errors while placing the center of mass in the tracker can occur, and also rounding errors, where results may not be precise down to each decimal, as we must round values, leading to small differences. Some further questions to end the discussion is: what if friction was not negligible? What would happen to the total momentum of the car system if there was significant friction on the track? Will momentum still appear conserved during the collision? If friction were significant, an external horizontal force would act on the carts, which would cause the total momentum of the system to decrease over time, meaning momentum would not appear conserved during the collision. The carts would slow down before and after impact, making measured momentum lower than predicted. Question 2. What does it mean if momentum appears greater after the collision? If the measured momentum after collision is larger, this usually indicates measurement errors such as velocity overestimation, mismeasured masses, or timing precision issues. Thank you.